Okay, let's do some homework. Number 4 asks, look at number 4, if you look at this picture, it says find the limit as x goes to infinity of g. Well, it looks as the inputs go out this way, it looks like the outputs tend toward or get closer and closer to 2. So this would be 2. So another way to say that is I can make my outputs as close to 2 as you want by taking x sufficiently large. Okay, we look at part B. It says as you go out to negative infinity, so as you head in this direction, do the outputs settle down to something? It looks like they settle down to this value, which would be -1. So as you go out to the left, it looks like it wants to be -1. So what is the limit as x goes to 0? Well, that looks like from both sides it wants to be negative infinity, because as you come in this way and this way, right? What happens as we go towards 2 from the left? As you go towards 2 from the left, it looks like it wants to go to negative infinity. From the right, it looks like it explodes to positive infinity. And then the equation of any asymptotes. Well, it looks like we have a vertical asymptote at x is equal to 0. We have a vertical asymptote at x is equal to 2. And it looks like we have a horizontal asymptote at y equals 2 is a horizontal asymptote. And we have a horizontal asymptote at y is equal to -1. So when we're thinking about vertical asymptotes, it's where the function explodes or grows without bound. And a horizontal asymptote, we're thinking in the long run, does the function settle down to some value? So that's number 4. Let's look at number 6. So if we look at number 6, it asks us to create a function that does the following. So first, it wants the limit as x goes to 2. Well, actually, let me show you all these things. I'm going to actually paste it in here for you. Let me go ahead and crop, paste. So this is a classic type of question where instead of, like we just did, going from the picture to the algebra, now let's go from the algebra to the picture. So if I start off with a set of axes, the first thing I want to do is, as we get towards 2, we want to explode. That's what this says. So as you get closer and closer to 2 from either side, the function grows without bound. So that would be a vertical asymptote. So that would be a vertical asymptote at x is equal to 2. Then, let's see, as we go towards -2 from the right, it wants to grow without bound. So as we go towards x is equal to -2 from the right, it grows without bound that way. As you walk in towards -2 from the left, it grows without bound, but in the negative direction. So maybe it does something like this, right? So now I've satisfied all of the top 3 conditions. So what we're trying to do is create a function that satisfies all these. So now, as we go out towards the left, the function wants to settle down towards 0, is what that says. So I guess as I go out this way, I'm going to settle down towards 0. As I go out to the right, the function wants to tend towards 0. So it does something like this. That would satisfy this. And the last one says f of 0, it wants to be 0. So if I want to be cute, I could just put a hole right here, and at 0, I could fill it in. So I could do that if I wanted to. But to make it look nicer, probably what I'll do is I will let it do something like this, where it's actually 0 there. So maybe that's something more like what I would expect. So now we've satisfied all those conditions. So that's number 6. Let's look at number 16. So for 16, we either find the limit or show that it does not exist. So for number 16, if I'm taking the limit as x goes out to infinity, I'm saying in the long run, does this function settle down? Well, in the long run, we're saying really it's a race to get big. So as x gets really big, as it grows without bound, who gets bigger faster, the top or the bottom? If the bottom wins the race to get big, it's going to pull everything to 0. If the top wins the race to get big, it's going to pull everything to infinity. If they tie, then we'll look at those leading coefficients. But the easiest way to really see that is to multiply the top and bottom by our old buddy, a well-chosen 1. So in this case, I'm going to multiply by 1 over the highest power. And you cannot read that because my handwriting is garbage. So 1 over the highest power. So the highest power in this case that I ever see is x cubed. So I'm going to multiply by 1 over x cubed, 1 over x cubed. This whole thing's equal to 1, so it's going to look different, but not really be different. So we're just going to change the form. So then when I multiply this, I get that x squared times 1 over x cubed. When I multiply this, I get x cubed times 1 over x cubed. Then when I hit this, I get negative x times 1 over x cubed. When I hit this, I get plus 1 times 1 over x cubed. But I think you see when you do that, you do not have to write the step I just did. I just did to show you all the gory detail. What you really have is this minus 1 over x, and then this would be 1 minus 1 over x squared plus 1 over x cubed. So yes, it is absolutely fine to go right from here down to that step. So now we just let x grow without bounds. So as x gets really big, this goes to 0 and this goes to 0. So the bottom is wanting to be 1, but this goes to 0 and this goes to 0. So we get 0 over 1, which is 0. So this function has a horizontal asymptote at y equals 0 because in the long run, it settles down to 0. Another way to say that is the function can be made as close to 0 as you want by taking x sufficiently large. So that's 16. Let's look at 18. Second verse. Same as the first, but in this case now we're going to have a limit as x goes out to negative infinity of 4x cubed plus 6x squared minus 2 over 2x cubed minus 4x plus 5. So again, as we go out to infinity, this thing seems like it would go to infinity over infinity, but that does not make sense, so we have to change the form. So we change the form. That's what's called an indeterminate form. We don't know what to do with infinity over infinity, so I have to make it look different. So in this case, I do 1 over the highest power, which again, in this case, turned out to be 1 over x cubed. And you get 4 plus 6 over x minus 2 over x cubed. 2 minus 4 over x squared plus 5 over x cubed. And now you let x get really large, but this time in the negative direction. Those are both going to go to 0. These go to 0, and you're left with 4 over 2, which is 2. So in the long run, as we go out to the left, this function can be made as close as you want to 2 by taking x sufficiently large in the negative direction. That is 18. Let's look at 23. Now here's where they get super interesting. So if I look at 23, I'm going to do the limit as x goes to infinity of the root of 1 plus 4x squared over 2 minus x cubed. Okay, so we're going to do the same thing we did before, but now maybe it's a little more interesting to think about what the highest power is. On the bottom, the highest power is 3. On the top, we're taking the square root of stuff to the 6th. So the square root of stuff to the 6th is the same as x to the 6th to the 1/2. So it's also x cubed. So really, the highest power we have is just x cubed. So I'm going to multiply this thing by 1 over x cubed, 1 over x cubed. when you do that, watch what happens. We get the square root of 1 plus 4x to the 6th over x cubed divided by, so let's make this line really obvious, this big divided by line here. On the bottom, it's going to be 2 minus x cubed all over x cubed. Okay. So let's see. So the bottom one, ends up being 2 over x cubed, and this is x cubed over x cubed. Right? So that makes me really happy because the bottom is going to turn out to be just 2 over x cubed. 2 over x cubed. Why do I keep on doing that? 2 over x cubed minus 1, right? But on the top, now we really need to think about this. What I would love to do is just have everything under the square root. And here's how we're going to do it. We are going to note that x cubed is very similar to the square root of x to the 6th. Right? They're actually exactly the same thing since x is positive. So if x is positive, you can just rewrite x cubed as the square root of x to the 6th because of the same thing. Let me show you. So if you have Desmos and you look at x cubed, so here is x cubed, and then we're going to do the square root. We're going to do the square root. Come on, man. It's going to be the last one I do, right? It's going to be the square root of x to the 6th. Oh, man, it didn't like that. X to the 6th. Notice, as long as we're positive, so as long as we're talking about x greater than 0, then these things are exactly the same. So the square root of x to the 6th and x cubed, they undo each other nicely as long as you're talking about a positive thing. Okay? That has to do with a subtle absolute value reason, which we won't get into right this second, but just know that these are exactly the same as long as we're positive, and one way I can see that is this to the 1/2, so I would expect them to be the same. So as long as x is positive, again, you can replace your x cubed with a square root x to the 6th. So I'm going to come in here and I'm going to replace this x cubed with a square root x to the 6th. But I know that the square root of a over the square root of b is equal to the square root of a over b. So I'm going to write this as the square root of all this stuff over this stuff. I think that makes you happy because you realize it's going to be 1 over x to the 6th plus 4, right? And so now what's great? Now what you do is you actually let x go to infinity. So I can drop the limit, and as x gets really large, a constant overgrowing large goes to 0. So on the top, it really just wants to tend toward the square root of 4. On the bottom, 2 divided by something growing goes to 0. So the bottom just wants to go to -1. So I think you'll see that this thing in the limit wants to be -2. Notice I didn't have to do plus and minus for this because we're not solving an equation. We're just evaluating the function square root at 4 And it's just going to have one answer. It's going to be 2 because the square root function is nice. Okay. Now, here's the cool thing. The reason I assigned the next question is because now it asks you to go in the other direction. So let me duplicate this, and you are going to see that 24 is very similar, except now what we're doing is we're going out to the left. So everything is going to be very similar. We're going to still multiply by that well-chosen 1, but now we're going out to the left. But let's see what turns out to be different. So here is what turns out to be different. Well, in this case, it turns out that if you're going towards negative infinity, these are not going to be exactly the same. If you're going out towards negative infinity, that is trying to tell you that your x's will all be negative. Well, since x is negative, x cubed and the square root of x to the 6th are not going to be exactly equal. They're going to be off by a negative. So if you ever want to replace x cubed with the square root of something, you must add this negative. You must introduce this other negative. Let's see if that's true in Desmos. Well, over here now if we go for x is less than 0, I would have to introduce a negative. So now you see that x cubed over here on the left and negative the square root of x to the 6th are the same function. So we really need that negative because they don't undo each other nicely over there. And again, it has to do with a subtle absolute value reason. Okay, so that means anytime you see x cubed, you can replace it with negative the square root of x to the 6th. So that means here, this is going to be negative the square root of x to the 6th. So this is going to have a negative out front. This negative right here is going to end up going out front. And so now when we take the limit, watch what happens. Again, we're going out to negative infinity. So now what happens is, from back here, we saw that all this was going to happen. So I can hit copy, and I can hit paste, put all that right there. And so x is going out towards, in this case, negative infinity. What's going to happen is you're going to have this negative chilling out here. So now when you put a root over root, again, because of this property, it's going to be one big root. And now as we let x go out to negative infinity, this is still going to go to 0. That's still going to go to 0. But you're going to have this negative on top. And this negative divided by a negative becomes a positive 2. So now as this function walks out towards the left, it wants to be a positive 2. Isn't that insane? So we have 2 different horizontal asymptotes for one function, and let's see that at work here. So what that function happened to be, let's do a fraction. Where's my fraction? Oh, I guess I'm just going to do divide. So on the top, I want the square root of 1 plus 4 x to the 6th. On the bottom, I want 2 minus x cubed. I want 2 minus x cubed. And look how pretty that is. As you go out in one direction, to the left, it looks like this function settles down to positive 2. And as you go out in the other direction, it seems like it settles down to negative 2. Sorry.